Numerical simulations drive our world, helping us track weather patterns, develop financial models, and push the boundaries of scientific exploration. Underlying these simulations are immense amounts of data, complex equations, and thousands of lines of code requiring a substantial IT infrastructure. Users can wait weeks or months for answers from simulations. In government settings, these delays and expenses can cause risk to the mission. ASRC Federal is proud to present SimAccel, an application that uses AI neural networks to get accurate simulation results in minutes, not months. Let's take a typical approach to simulation use in DoD mission planning. A planning analyst wants to assess our vulnerability to attack given our current defensive posture. They provide mission planners inputs, like where a strike may come from and where our assets are located. A simulation engineer configures these inputs into the simulation, which is then run. Based on the results, analysts can either choose to run new scenarios or develop plans to inform alternative courses of action. But when we look at the path from running the simulation to getting results, we find that simulations are hampered by waste coming from processing unsuccessful configurations and long delays, as high-fidelity data can take weeks to process, costing time, money, and computing power. With SimAccel, we reduce these costs. Mission partners provide us sample simulation data. Our data scientists run this data through rigorous neural network training and develop models that we deploy back into the partner environment. SimAccel is broken into two modules: Direct to Answer, which pre-identifies stable simulation configurations, and AutoEncode, which generates low-fidelity data that can be reconstructed for visualization. What customers get is our SimAccel API. When users log in, they'll see all the models our data science team has designed for their simulations. When users click on a model, they will see a model card that contains all the building blocks and parameters used to train the neural network. To run a model, users go to Runner, select the model they want to run, and upload the specific scenario inputs they would like to simulate. The user runs the model, and SimAccel produces pre-identified simulation configurations that will be successful in the full simulation run, alongside low-fidelity data that they can reconstruct for fast insights. Let's return to the typical process. Without SimAccel, simulation users spend precious time, money, and compute processing unstable configurations and wait days or weeks for their full results. But SimAccel can identify 99% of usable configurations and reject 70% of potential errors before the simulation runs, avoiding waste. Users take usable configurations and, using SimAccel, pre-process working inputs to generate notional results without having to run the full simulation with 99% accuracy at 60 times speeds. With SimAccel, users have more time and compute available to improve data exploration by running more scenarios in the same time frame, offering users more data, effective planning, faster time to action, and reduced risk for any objective.
Across both the DoD and space missions, this is an opportunity for them to do these calculations at extremely high rates of speed, to explore a much larger fitness landscape and hopefully get more valuable information out. There's two primary methods that are being used right now to improve the speed of existing simulations. Number one is the ability to just throw more compute at it. So throw additional hardware, supercomputers. The second aspect is doing refactoring and changing the code. SimAccel, the big benefit is it runs completely independent of all of that. So any speed gains that you would get from refactoring or throwing additional compute at it is a multiplier to how SimAccel functions.
We've had proven success with our mission partners at MDA and NASA.
So MDA did a solicitation. They were finding cases where the existing tactical code, which is a very complicated algorithm, was not producing the expected results, and they couldn't figure out why. We partnered with the source system of record for the high-fidelity simulator that they used, and we applied our neural network models and expertise. We developed proprietary models for them that was able to accelerate the process of their data generation by over 60 times. The most exciting part of the work for NASA, one, is the applicability that everybody can understand the value. They're looking at alternatives that they can't anticipate. So what happens if one of their engines goes out? All of these different off-nominal trajectories. We focused on their path back from the lunar orbit. We want the ability to give them a dynamic solution for how to get people back safely. We were able to show that we had a savings of over 70 days of reduced compute with a 99.5% accurate ability to reconstruct mission availability.
ASRC Federal is excited to support future partners with SimAccel.